Hello and a very warm welcome to everyone joining us for today's event, Pioneering Sustainable Aviation Together, an event hosted by two giants of the aviation industry, Safran and GE Aviation. For the next hour, we'll be focusing on the next chapter in sustainable air transport. How will the industry meet its commitment to halve emissions by 2050? Now, we know that the road to decarbonisation will require innovation and investment, which is why we're also giving you an exclusive preview of the new technology program to be developed by both Safran and GE Aviation through their unique partnership, CFM International. Now, I'd like to take this moment to also tell you you can send through your questions at any time during our discussion. We will come back to them in the second half of the session. I now have the pleasure of welcoming our two main speakers for today, Olivier Andreas, CEO of Safran, and John Slattery, President and CEO of GE Aviation. This is the first time they're sharing the stage together. Over to you, gentlemen.
Good afternoon, John. It is my pleasure and honor to welcome you today here in Paris.
Merci beaucoup, Olivier. It's great to be here.
For everyone joining, this is our first physical meeting since our respective appointment as CEOs. And it is really a great privilege for Safran that it takes place in our Research and Development Center here in Paris. The history and success of our two companies have been closely linked for nearly 5 decades through our unique partnership, CFM. Today, the aviation industry is undergoing more transformation and turbulence than ever before. We are here together to launch the next chapter of CFM, to develop solutions that will enable a sustainable future for our companies and our industry.
Well, Olivier, I'm very pleased to be here with you today. You'll recall, and I'll share it with everybody joining, on January 1st, when we had our first conversation as you took over as Group CEO here at Safran, I committed that my first international trip would be to come here to Paris to visit with you. And whilst, Olivier, it's not without its challenges to everybody here that's joining us, being able to travel internationally, well, it signals the continued recovery of our industry. It's welcome news for our airline customers as well as you, our colleagues, and indeed your families. And significantly, we're here in the city that hosted the UN Convention and led to the Paris Climate Accord back in 2015. GE Aviation fully supports the United States' decision to rejoin the Paris Agreement, which includes nearly 200 countries already. The aviation industry has been a leader in developing and embracing a global framework for cutting CO2 emissions. Coordinated global action to limit the rise of global warming, it's vital for our health of our planet and our shared communities. It's innovation now that we need to meet this challenge, and that's our noble cause.
Ladies and gentlemen, we are here today to reaffirm the commitment of Safran and GE Aviation to sustainable air transport. Our joint efforts will involve a technology development program to support the future launch of a new CFM engine to succeed our extremely successful LEAP. We aim to offer an additional 20% decrease in fuel consumptions and CO2 emissions by 2035. To reach this goal, we will be working hand in hand, just as we have always have in the past. This symbolic alliance, unprecedented in the 70s, was given the seal of approval by the Presidents of the United States and France, Richard Nixon and Georges Pompidou. Over and above this unique industrial saga, we share a common vision, and we represent two countries with a common commitment to accelerate the fight against climate change.
So today, Olivier and I are delighted to announce we are extending this historic partnership between GE Aviation and Safran to 2050. Our CFM joint venture unites two great innovators on either side of the Atlantic and draws from the best of our people and our cultures. We have been, and we will be, extraordinary together. As you saw in the opening video, we've been working now hand in hand for nearly 50 years already through our joint company, CFM International. We literally connect the world. Our CFM engines have accumulated more than 1 billion flight hours and carry millions of passengers every single day. The efficiencies offered by the CFM 56 helped expand air travel, fostering connections between people and supporting global economic growth. And our LEAP engines, they've reduced fuel consumption by a further 15%. In just the last 5 years, we've delivered around 4,500 LEAP engines, and our backlog stands at more than 9,000 engines and growing. But today, we are at a point of inflection. As once distant commitments now draw nearer, we must act with a burning sense of urgency. Our need to earn the right to grow as an industry, we must rise to that challenge of decarbonization. And meeting the industry's commitments to halve CO2 emissions by 2050, well, that requires a vast collective effort. There's no single technology or indeed company that can do this alone. As Olivier and I have discussed many times, we need public policy that aids this development of breakthrough technologies and supports the development of alternative fuels. We also need an air traffic control system that offers greater operational efficiency than we've ever seen before. And we will work closer than ever with our airframe partners to optimize the design and enhance airframe and engine integration.
Since the founding of CFM, our tremendous efforts in terms of research and innovation have allowed our engines to reduce fuel consumption by 1% per year on average, while also significantly reducing noise. Cutting fuel consumption by 40% in 40 years is a tremendous achievement. But that is not enough. We now have to proceed twice as fast. The industry has committed to reduce emissions by 50% by 2050, with a projected increase in air traffic. That actually means the next generation of airplanes must reduce emissions by 90% as compared with the current fleet. This reduction will come from three areas: fleet renewal and technology breakthrough on aircraft and engines, sustainable fuels, and improved air traffic management. Innovation and investment in research and development will be the key to decarbonization. GE and Safran have invested billions of euros over the past decade to develop new technologies. Given the extensive funding needed to develop a brand new engine, our continuing involvement in research programs backed by our governments is essential to success of CFM's technology maturation program. But engine advances alone are not enough to meet the industry's goals. One essential key to success will be the use of sustainable aviation fuels. Our disruptive engine will be able to run with 100% SAF and will also be compatible with liquid hydrogen. Today's engines are certified to run with 50% SAF, but currently the industry is using only 0.1% sustainable fuel. We believe that the production and availability of sustainable fuels should be prioritized for the aviation industry. But there will be no offer without demand. And it is important that the regulators drive the industry towards this solution, which is technically accessible today. We cannot wait for 2035 in order to achieve significant CO2 emissions reduction. If we are to achieve our ambitious goals, we must accelerate with SAF today.
GE has been heavily involved in SAF testing and development for many years already, including powering the industry's very first 100% SAF flight back in 2018. Today, all current GE and CFM commercial engines can already operate with blended SAF, up to 50%, without hardware modifications. And we're now leading efforts to define standards that will enable 100% SAF to be used as drop-in as a replacement for Jet A. We're encouraged that governments right around the world are beginning to recognize the need for policy and regulation to support broader adoption of SAF. We're also supportive of and excited by research into the role hydrogen may play as a fuel source in the future. As an industry, it's vital that we accelerate growing momentum right around the world for SAF adoption, whilst also continuing to research use of hydrogen as part of that longer-term effort to decarbonize.
John, everybody at Safran is extremely proud to be able to kick off this new CFM program with our partner GE Aviation. In close collaboration with our airline and airframer customers, by working together across the whole industry, we will be able to develop a real game changer and write a new chapter in aviation technology.
I believe in it, Olivier, and I'm more than excited to join you as we stand here today and make history. Innovation and development of groundbreaking technologies, they're the lifeblood of both of our enterprises. We're energized by the challenge of this moment. Today we stand on the shoulders of giants that went before us. We look forward with confidence and a bold vision for reinventing the future of flight.
Thank you very much, Olivier and John, for that introduction. Now, you announced the launch of an exciting new engine technology development program, and now is the moment when all will be unveiled. To do so, I'm delighted to welcome Francois Bastin, Vice President, Commercial Engines for Safran Aircraft Engines, who will then be followed by Mohammed Ali, Vice President and General Manager of Engineering at GE Aviation, both of them here to guide us through.
Good afternoon to everyone, or good morning. On behalf of our teams all over the world, I'm proud to unveil our new development program. As John and Olivier mentioned, this ambitious plan joins GE and Safran to embrace our sustainability imperative and represents one key enabler to help reduce the environmental footprint of our aviation industry. We believe this bold new program will reshape the future of aerospace propulsion. That's why it represents such an exciting challenge for all of us. A challenge that will embark our CFM teams, our customers, airframers, airlines, and our suppliers and partners. The incredible innovation capacity within GE and Safran is mobilized to develop groundbreaking technologies for the next generation of CFM engines. We have a clear ambition and a clear path to achieve it. We will deliver to our customers 20% improvement in fuel efficiency, therefore at least as much benefit in CO2 emissions. We will also significantly reduce noise emissions for the passengers. All this while living up to the best CFM standards in terms of reliability and cost of ownership. Ladies and gentlemen, this ambition has a name. I'm honored to share with you the CFM RISE program. RISE stands for Revolutionary Innovation for Sustainable Engines. The RISE program will leverage the best assets from GE and Safran, including our joint experience around unducted fans, composite fan blades, additive manufacturing, ceramic matrix composites, or hybrid electric technologies. This level of innovation will require closer integration with the aircraft manufacturers than ever before. Engine installation will be optimized together with the airframers and approved by the airworthiness authorities, since there is a variety of options for installing an open fan engine, for example, at the rear of the fuselage. or under the wings, with either a high wing configuration or a low wing configuration. RISE is a breakthrough technology demonstration program that embodies CFM's mission to push the limits of innovation and contribute to protecting our planet. To hear more about it, Mohamed, the stage is yours.
François, thank you very much. It's indeed an honor to be part of this very exciting event. Make no mistake about it, we face a historic challenge. Through the RISE program, the next generation CFM engine will enable a sustainable, zero carbon world by achieving the single largest improvement in fuel burn we have ever made. The purpose of the development effort is to both demonstrate the promised performance as well as mature the technologies that we will deploy in the next generation CFM engine. The effort now known as RISE actually began in 2019. But by the end of this year, our joint development team will double, encompassing more than 1,000 engineers across GE and Safran. Our first full engine ground tests are scheduled for around the middle of the decade at both GE and Safran test facilities. That will be followed by flight testing using the GE flying test bed. We have a comprehensive demonstration roadmap that includes more than 300 separate component, module, and complete engine builds. In defining this program, we are able to draw on decades of experience and the best technologies from both GE and Safran. To be clear, and I want to be very clear here, our goal is to open the envelope. We are stretching ourselves. There will be learnings and maybe setbacks. But we are resolute, and our objective is very clear: inventing the future of flight and making it sustainable. Increasing fuel efficiency by more than 20% not only enables decarbonization, but it's also critical in enabling broader use of both sustainable aviation fuel and hydrogen. This makes it more affordable for more people to fly to more cities while protecting the planet. And above all, it's with safety first. Today, we are pleased to share the broad outline of this vision. Let's take a look.
Good morning from Cincinnati in the US. I'm Ariane Hageman.
Good afternoon from Villaroche in France. I'm Delphine Dijon. We are excited to build on the rich history of the CFM partnership as we launch this new adventure and share some of the details of the CFM RISE program.
With this program, GE and Safran are continuing to revolutionize commercial aviation with uncompromising technologies that will help us achieve some very ambitious sustainability goals.
Our objective with the CFM RISE program is to demonstrate more than a 20% reduction in fuel consumption and carbon emissions compared to today's most efficient engines.
These reductions represent the single largest decarbonization improvement we have ever achieved. Our extensive technology demonstration program is already well underway, with several RIC tests already successfully completed. We're focused on 3 key technology pillars: advanced architectures, advanced materials, and hybrid electrification to achieve our efficiency improvement.
We are evaluating several promising architectures as part of our technology maturation plan. The most ambitious, the one that will yield the greatest benefit, is open fan architecture. For the open fan, our vast experience with carbon fiber composites is enabling us to achieve a larger diameter, optimizing aerodynamics and acoustics.
The resulting step change in propulsive efficiency actually represents a significant part of our expected efficiency gains and corresponding reduction in CO2 emissions. We are combining that with a lighter, more compact, higher speed booster and low pressure system.
This will help optimize engine operation across each segment of flight, providing further improvements in efficiencies and emissions reductions.
The other part of the equation is the increased thermal efficiency that we will achieve through advanced core technologies. We're developing a high temperature, compact core design that will yield very high compressor pressure ratios.
To achieve this higher thermal efficiency, we are expanding the use of next generation materials that have lower weight and higher temperature capability. Together, all those technologies combined, this system of systems will deliver more than 20% improvement at the engine level. And when this technology is coupled with sustainable aviation fuel and hydrogen fuel, we reduce CO2 emissions even further.
Obviously, the advantage of this reduction is that it provides for both significant extended range as well as becoming a key economic enabler for more sustainable and zero-emission fuels. The next technology we are going to highlight is hybrid electric. CFM is the first company to develop this technology for the single-aisle aircraft. This system will optimize engine performance by providing additional electric thrust while also generating electricity both for itself as well as for the aircraft.
By embedding a generator in the engine, we will bring flexibility to engine controls throughout the entire flight envelope. Both GE and Safran have extensive experience and competencies in this field that will be brought to the CFM RISE program.
We will also introduce an advanced waste heat recovery system that will allow us to distribute heat more efficiently throughout the engine to contribute to reducing emissions. All of these interrelated systems are optimized through a series of advanced controls that help us monitor the engine remotely, minimizing the need for engine inspections and for maintenance activities.
We will ultimately provide an engine that meets the thrust requirements for the single-aisle market with the same flight speed and engine reliability that customers count on from CFM today. The CFM RISE program is bringing the full financial and intellectual strength of two world leaders to demonstrate and bring to market technologies, with no compromising on fuel efficiency, noise, emissions, engine reliability, and cost of ownership. The GE and Safran teams are extraordinary together.
The CFM RISE program embodies our shared vision and long-standing commitment to lead the path to zero emissions. Together, we are redefining the future of flight.
Today, we are rising to the challenge.
Thank you, Delphine and Ariane, featuring in that video. Now, as I mentioned earlier, the leaders of both Safran and GE Aviation are also here to extend the historic partnership CFM International until the year 2050. I'm delighted to welcome back both CEOs here onto the stage to formalise the next phase of this joint venture.
Thank you.
Thank you, Mairead. This is the future of flight right here, Olivier.
We're making history here, John. I'm thrilled with that.
We're humbled to be your partner and to invent the future of flight doing it. You know, Olivier, I asked one of my colleagues just before we came up, what is the distance between Evendale and here in Paris? And it's roughly 4,200 nautical miles. I have tens of thousands of colleagues that are watching, as I'm sure you have. They want us to shake hands, so we have to adhere to the layers of safety. Right under we have some gel. But I think it's important that we mark this partnership as it now brings us to the middle of the century with a handshake.
John, thank you so much.
Let's do it.
Let's do it.
And with that, that does bring us to the second half of our session here. That is, of course, questions and answers from our journalists. I did invite you earlier to send through your questions. There is still time to do so, and we'll try to address as many as we can in the time ahead. Let's get moving with the very first question. Question 1 comes from Aviation Week, How have you structured your relationship with Airbus and Boeing on this?
I guess if I could kick it off, Olivier, our relationship with Airbus and Boeing just continues exactly as it is. What I would say is we have engaged with both Airbus and Boeing in advance of today to share with them the ideas around the technologies that we're going to develop during this program. We could see their excitement. It's up for Airbus and Boeing to comment in the public domain, but we have a great relationship with them, and I think they're really looking forward to the sorts of innovations that are going to rise out of what we're about to do.
And John, at the end of the day, it's going to be an airframer decision to decide when and how they are going to launch a next aircraft program, and by which timing. And of course, we want to be in a position to offer the best possible engine options to them.
Thank you very much. We'll move on though now to the second question that comes from Runway Girl. Does that specifically target the Airbus hydrogen program that should be ready around that time? And we did anticipate this question, did we not?
It does not specifically target one single airframer program. As we said, this next generation engine will be capable of being operated with 100% sustainable fuels, including hydrogen. It's important to say that 90% of the engine would remain the same whatever the fuel is, 90% of the engine. So the hydrogen option is potentially compatible with our next generation program.
Just to complement that as well, because sometimes I wonder if we drove past some of the key statistics that are really important. When we talk about a 20% reduction in fuel burn, that's a reduction relative to today's kerosene A1. If we were to put just SAF into that new engine, that would reduce CO2 by 80%. And Olivier, as we discussed, if it was hydrogen, which is kind of the nirvana, that would reduce our CO2 emissions by 100%. And the aircraft, the engine, will be hydrogen enabled. But we are here to serve our airframer customers. We'll work to their timeframe.
Thank you very much. We'll move though on now to question 3. Ready for it? This time it's for Olivier. Where does from Aviation Week, I might add, where does your program fit into the clean aviation public-private partnership?
It does, and we have already discussed with the French government on one side on this project, and we shall receive funding for that from the French government in the frame of the relaunch, the so-called relaunch plan. And we have been entering into discussion in the frame of clean aviation. Yes, indeed. So this program, I expect, will be supported by the European Commission as well.
Thank you. We'll move on now. We've got a question here from the French newspaper Le Figaro. What could be the budget of the RISE program? Can you give us some colours on the calendar and the main steps, testing, first flight, entry into service?
We are not going to share any specific numbers with you today. I mean, this program is going to be part of our research and technology effort. As far as Safran is concerned, we've already said that we would dedicate 75% of our research and technology efforts to the decarbonation. And this project is really a significant part of it. I will let John comment on the GE side, of course.
We've invested a not dissimilar number. Last year was 1.8 billion. It's a 1.8 billion again this year. We haven't identified what the breakout is for this program, but it's a significant percentage of it. And in fact, by year end, Olivier, between us, we're going to have 1,000 engineers dedicated just to this program. So it's starting with real momentum. Of course, we've been working on this program since 2019.
1,000 engineers. Right, okay, moving on. A question here that's come through from Air Cosmos. What will be the main technological issues the RISE program will have to overcome, composites or hybridization?
There are so many new technologies that are coming onto the program. You know, if you start with the open fan, which we have a lot of tacit knowledge between both organizations on. Of course, it will be hybrid electric. There will be a lot of new materials composites that we'll be bringing in. We will have a gear on this engine, of course, because it's open rotor. There are a lot. I think Mohammed in his remarks mentioned that we'll be building 300 different modules, experimenting with them as we go. So I don't know if we want to call out any one in particular, but there's a lot of exciting innovations rising out of this.
But the key point, John, to complement you, is that the open fan is the one architecture that will bring us the most efficient, the most significant propulsive efficiency. So this is a disruptive architecture, but as you said, we have already deep experience and deep knowledge on this kind of architecture. GE in the 80s has demonstrated an engine program called USF, Unducted Single Fan, which was an open fan. And we at Safran, we have demonstrated the open rotor demonstration program a few years ago in the frame of Clean Sky. We, Safran, had onboarded on the GE project in the 80s, and GE had onboarded on our open rotor project more recently. So we have a deep experience in the open fan, and we will continue to mature and demonstrate those technologies.
And the thermal efficiencies we're going for in that new compact core with those new materials, I know that the engineering teams are excited about that as well, complementing that propulsive efficiency we're going to get.
Okay, thank you very much. I've got a question that comes now from Aero Society. Is 20% reduction in emissions a conservative estimate for what an open rotor could achieve? Wasn't there 30 to 40% savings in fuel promised at one point by open rotor?
If I may go first, Olivia, on this one, I would say that as we look at the challenge that's in front of us, particularly around the climate and our need to drive and lead and influence with our partners, our airframer partners, that charge towards zero carbon emissions. This, we believe, is the engine that will start us on that path. So standalone, we talk about 20% just from that engine. But we need to complement and understand that it's the engine technology coupled with the new synthetic or sustainable aviation fuels or hydrogen. But in the aggregate, that gets us to 80, 90, 100%. And Olivia, you said it in your remarks. To reach the requirements we've committed to as an industry, the new engines, the new aircraft have to be 80 to 90% more efficient than those today.
Absolutely. Absolutely. And remember, the engine is one component of the overall aircraft efficiency. Of course, we would tell you it's a significant component, bringing 20% complemented by additional improvement on the aircraft side, and there will be a lot, I'm sure, on the aerodynamics and so on. I'm sure that the combination aircraft plus engine could bring up to 30% of improvement by 2035.
And the air traffic control systems need to play their part in it as well, helping us be more efficient as aircraft navigate around. So it's a collective, this is a team sport.
Well, there's lots of questions here on the rotor design, because I've got question number 8 here. How does this rotor design connect to the previous GE and open rotor demonstrators? What have you learned and incorporated from them?
Well, I'm going to phone a friend on that one, and we happen to have a friend who will give a very technically specific answer. Mohammed?
It's a great question. So, as I think John and Olivier said, both GE and Safran have been making multiple evolutions and gaining experience with this architecture, starting all the way back to the 80s. How we recently also have been able to use these learnings, in both companies, in addition to tremendous utilization of computational power that became more recently available. And now we are able to actually make it a single fan. In the past, it was dual counter-rotating fans, and design blades specifically for that. That not only reduces the weight and reduces the complexity, it opens up the efficiency, as well as it creates the same comfort that all the passengers, from a noise perspective, that all the passengers have come used to. And we are actually very excited about these breakthroughs, the combination of our tremendous experience with that architecture, in addition to the most recent learnings we have achieved in rigs and the computational power that we have added in here.
Do we
And
validate?
without any compromise to the speed of the
To
aircraft.
the speed of the aircraft, absolutely.
So we validate that phone a friend response?
Yes.
Yes.
Very good. Moving on though now to another question from Green Air News. How strong is the appetite from open rotor architecture from Airbus and Boeing? And have you researched the same question from travellers?
Well, you would have to ask the airframers their opinion, but I have to say that, and I think, John, you mentioned it, we have engaged with both of them on our technology plan, and they are really interested in the efficiency we are able to bring by 2035. So the open fan architecture is recognized as offering this kind of fuel burn reduction.
And
But you would have to ask them.
Yeah. When we think about the traveling public, their true north going forward increasingly is reducing those CO2 emissions. So the airframers will be talking to the traveling public, as will we, but we're excited, and that we will share more, I guess, in the months and the years ahead as we collaborate with the airframers.
Let's move on now to a question about RISE, which of course we heard about during our session today. It's a question from Bloomberg. Is CFM in discussions with Airbus and Boeing about placing a RISE-originated engine on future aircraft yet?
Be mindful. This is not an engine launch that we are announcing today. This is a launch of a technology maturation and demonstration program. When you are at a point of launch decision for be it an aircraft or an engine, you need to ensure that you have matured all the technologies before, upstream. So this is what we are doing today. This is what we are launching. So time will come when an airframer will decide to launch a program, and if they get on board our engine offering, then time will come to discuss, this kind of thing.
Moving on now to another question from Thomson Reuters. It's quite a long one, bear with me. How do you expect Pratt & Whitney and Rolls-Royce to react to this move? And Olivia, when it unveiled an open rotor demonstrator, Safran said it was also looking at efficiency improvements to more traditional gas turbine engine architecture. Where do you stand on that?
I'll take the first part of it on Pratt and Rolls, if I may. I hope I don't get this wrong, Olivier. We're here today as partners to work with our airframer partners to invent the future of flight. We're doing that because we truly believe this is a noble cause, to bring the world of aviation to ultimately a zero emission future of flight. If our friends at Pratt & Whitney and Rolls-Royce are listening, I would encourage them, engage now, compete with us. Bring your best engineers, surface the best technologies you can, let us compete. Because ultimately, the planet will be the beneficiary. Competition makes us better, so I welcome their competition, and let's go for it.
With respect to your second question, there's a common block of technologies that we are going to develop here that could apply to any kind of architecture. As I said before, the timing of an aircraft launch is an airframer decision, and the aircraft configuration is also an airframer decision. And it's up, at the end of the day, it's up to the airframer to select what they consider as the best possible engine option. So we want to position ourselves to be able, by that time frame, to offer the best possible option without the required maturity in terms of technology. So those technologies that we are going to develop, further composite technologies, composite fan blades, new alloys in order to improve the thermal efficiency you were mentioning, John, additive manufacturing, all those technologies are a common block that could apply to any kind of new engine launch with whatever architecture.
Thank you very much. have another question here from Le Figaro. What about the main steps of the RISE program? Testing, first flight, entry into service. They want more details here.
Do you want to pass
François?
this over to François?
François.
Yeah, I can give a few elements about that. We're thinking of testing engine modules and engines mid of the decade, and ground testing and go flight testing in the wake of that. About entry into service, we're targeting the middle of the next decade.
Okay, short and succinct and right to the point. Okay, question from Financial Times here, which you may have touched on, but are you hoping to offer this engine to Boeing for a new plane the company might launch this year?
Again, if I may, as Olivier had said, what we're doing today is launching a development program, not launching an engine. I don't want folks to get confused with that. And again, I'll mirror what Olivier said. If Boeing, or indeed any airframer, launches a platform and the business case makes sense for us, then we will present our best aggregate technologies that we have at that moment in time. Whether that's this year, next year, the year after, if it's before the ground test that Francois was talking about, or whether it's afterwards. So we're constantly developing technologies, but the suite of technologies here are a lot more advanced than anything we've ever done. So, but we'll be ready. If Boeing offers a platform, we will compete strongly to be on board.
Great, let's move on to Aerospatium here, a question. When do you plan to switch from the RISE demonstration program to an actual industrial development for a successor to LEAP?
It's very simple. As soon as an airframer takes the decision to launch a brand new aircraft program.
Right on. Next question, at what noise levels RISE will run and how does it compare to the LEAP?
Both the cabin noise and the exterior noise will not be, and there will be no degradation relative to what's experienced on our best technology, which is the LEAP today. So it'll be a great passenger experience. And from an outside airport experience, you should not see any degradation relative to where the LEAP is. That's our minimum commitment.
I can confirm, John, exactly what you said. On the open rotor that you have tested, the noise level was exactly the same as the LEAP engine.
Brilliant. I have another question here. We have many here, but we're getting through them. From ATW, from a pure technology perspective, what is the biggest challenge of this program?
I think John talked about it. We are actually super excited. I mean, I'll talk as an engineer here. This is nirvana, right? We are super excited about not just embracing the challenge of sustainability, which is, as a human, I care a lot about for myself and for my children and my grandchildren. But I'm excited that we are developing a whole suite of technologies. Each one of them is very challenging. So we talk about the open rotor architecture or open fan architecture. We talk about hybrid electric. We haven't talked much yet about that, but this new technology demonstration program is very capable in hybrid electric capability. We talk about the advanced materials that we are going to have to develop, and we are in the process of developing to make this happen and increase the thermal efficiency and enable the propulsive efficiency that we have talked about. We talk about the aerodynamical performance, that the massive computational power that we have been actually garnering in the past several years to be able to achieve that. This is all very exciting, and then you couple that with it becomes, on our vision for it, it's 100% sustainable aviation fuel, and in addition to that, being hydrogen capable, which each one of them has its own sets of challenges. It's very exciting about our ability to help inventing that future of flight and our vision for it being sustainable.
Nirvana for engineers, I like that.
It's phenomenal.
I have a question here from Flight Global. What are the top challenges associated with open fans, and how will you address those challenges?
I think we already spoke about that. Certainly, we have tremendous experience with this architecture. We have done multiple testing, including, I want to remind everybody, flight testing as well. The ability to make these big fans to increase the propulsive efficiency That plays to the joint material capability of both companies, of the ability to invent and industrialize composite fan blades. We have unprecedented capabilities, I think, in both companies to be able to achieve that. The aerodynamical shape, I think, is quite attractive to all of us as engineers and how we perfect that. So we actually create not only the propulsive efficiency, but in addition to that, better or equal noise experience to what the communities and what the passengers have been used to. And at the same time, at the same speed of transportation of the aircraft that all the passengers have been used to. It's a very exciting challenge to be able to write that new chapter for all of us.
Thank you very much,
In some ways, I would say, to complement, it's not just the open fan, but if you're to think about the quantum of new innovations that we're working on, it's bringing them all together. Maybe that's what it is in some ways, because you have plenty of experience in open fan, which we've worked with you on in the past. And vice versa, back to the 1980s. Yeah. So these are a series of challenges our engineers are embracing.
Same on hybridization, where both companies are working. So that's another path.
And on gears, where both companies are working together.
And on gearboxes as well. Yeah. Absolutely.
We think we got it.
Well, let's see if you've got the next question from Usine Nouvelle. It's quite technical, so why is there a fixed fan on your video instead of contra-rotatives?
Oh, okay. You are coming to a sweet spot here, so thank you for the question. It's certainly the counter-rotating. You can think of it, it's just additional complexity and weight. So certainly, we actually think that that's a leap forward, no pun intended, in being able to maintain the same level of requirements of efficiency, noise, and aircraft speed, and not having to do a counter-rotating capability. We believe we actually have mastered that science and technology, and we have demonstrated that through our simulations as well as our rigs that both companies have been able to do. So we are actually quite excited about the ability to simplify the architecture and achieve or exceed the requirements of this new technology development.
Thank you very much. Now there is perhaps time for just a couple more questions. They're just popping up here. Hang on. No, I've been told that our time is up. No, here, there's one. They've given us one more here and here. SAF and H2 seem like two different goals for this architecture. Can you talk a bit about the testing path for development for each one?
Well, we have already launched testing for 100% SAF. You may have heard that last week we have announced a flight test with an A320neo powered by a LEAP engine that is going to work and be operated with 100% SAF. So through this test, we are going to learn a lot, and we are going to see how far we can go, increasing the current 50% certified SAF mixed for the current engine, including LEAP, to a level that could potentially be higher. So we are going to work on that. On hydrogen, we'll have to test, and we'll be discussing with Airbus a testing at some point in time of a hydrogen-powered aircraft. But be aware that we have already launched a study between Airbus, Safran, and Ariane Group, which is our joint subsidiary active in space rockets, and which has a 50 years experience in liquid hydrogen powered rockets.
Thank you very much. I've got another question from Airgreen. It's something we haven't touched on. Will you need other industrial partners to develop the electric related elements? And my question has just dropped off there. Will you need other industrial partners?
This is a team sport. We're going to need governments to come together on regulation. We're going to need governments to come together on funding. We're going to need airports to come together and the ecostructure and infrastructure that's required at airports. We're going to need the airlines to support what the airframers want to do as they push forward. There's no pride of ownership exclusive just to us. It's a team sport. I would encourage the other engine manufacturers to step up and compete here now, because the noble cause is bigger than any of us. And this is really is an industry team sport to protect the industry.
Well, thank you very much. Thank you very much. That's all we have time for in terms of question. I'd like to thank you very much for participating in this discussion, for listening, and I'd like to offer the final words to both John and Olivier.
John.
Olivier, on behalf of my colleagues that have been here all week, on behalf of the 40,000+ GE Aviation colleagues around the world, we're humbled to be here to extend the partnership, that you're willing to extend it out to the middle of the century with us. We have a big job of work ahead of us, but you can count on us, and thank you.
Thank you, John. On behalf of the Safran employees, we are very glad and thrilled by what we are announcing today and opening this new chapter of our CFM strong history, pioneering the sustainable aviation together.
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 Merci beaucoup.
Merci.